finally, this is our last lesson video. See, while y'all have all been sitting at home on Friday, I've been having to make all these videos, but that's fine. All right, so this is the last one for chapter 18. So we talked about geothermal energy, solar energy, wind, hydroelectric. So now we're going to move on to tidal energy. So tides are caused by the gravitational pull of the moon and the sun. So like if you're at the beach, sometimes there'll be high tide where it comes up the beach a lot. Sometimes there'll be low tide where it doesn't come as far up the beach. And that's caused by the rotation of the earth with the moon and the sun. A dam across a bay can harness the energy of large tides to generate electricity. So as more water moves in or more water moves out, it can spin turbines. And as we've said, if you can spin a turbine, you can generate electricity. So water at high tide gets trapped on the land side. As tide recedes, the water falls through the dam spillway and turns a turbine. Like I said, if you can turn a turbine, you can create electricity. So what are some of the problems with this? Because it sounds pretty awesome. Well, few places in the world have tides large enough to support this mode of energy. Like when I go to the beach, a lot of times the difference in high and low tides may be only about 5 feet on the beach. It's not really that big. So you have to have a specific area where there's a really high and really low tide. It has a high economic cost. You're building like this underwater dam almost. And then you're going to disrupt the environment. Like if you're building dams in the ocean, then all that ocean wildlife is going to be disrupted. So, energy solutions, conservation and efficiency. They're two different things. So energy conservation and energy efficiency accomplish the same goal but through different means. So energy conservation is using less energy by reducing energy use and waste, for example. So in energy conservation, we try not to use as much energy. So that would be, I'm leaving the house, so I'm going to turn my lights off. That's energy conservation. Energy efficiency is using less energy to accomplish a given task by using new technology. So for example, energy efficiency would be, I'm going to replace my old light bulbs with LED light bulbs because I can get the same amount of light, but it uses less energy. So that's the difference in those two. So even though the U.S. has become more energy efficient, energy consumption continues to increase. So per capita consumption in developing nations is substantially less than in developed nations. However, the greatest per capita increase in consumption is occurring in developing countries like China and India. So the problem is, not only are they using a large amount of energy, these are two of the most populated countries in the entire world. So it's a lot of people using a lot of energy. This rising demand accompanies increases in economic development and population and use of older, less expensive, and less efficient technology. So all these people, they're trying to become industrialized, so they're using old, inefficient technology that we've moved on from in the United States. So we need to balance the economic development with controlling environmental degradation. So we want these countries to become more industrialized and become developed like we are, so they're not having as many issues with undernutrition and things like that, but we need them to do it in a way that doesn't kill the environment. So we have a lot of energy efficient technologies. So development of more efficient appliances like Energy Star appliances, automobiles that get more miles to the gallon, buildings with our insulation, industrial processes, they all help reduce energy consumption. So CFLs, or compact fluorescent light bulbs, they produce light comparable to that of the old incandescent bulbs, but they require only about 25% of the energy and last up to 15% longer. So replacing your old incandescent light bulbs with compact fluorescents, or like I said earlier, LEDs now, that is a way to be more efficient. You get the same amount of light, but use less energy. Condensing furnaces require 30% less fuel, and super insulated buildings use 70 to 90% less energy. So with all of these things combined, we can reduce how much energy we end up using. So the National Appliance Energy Conservation Act of U.S. set national appliance efficiency standards. So refrigerators today use 80% less energy than in the 1970s. Automobile efficiency has improved dramatically since the 70s because they use lighter materials and drag-reducing designs. That's why you see cars are really smooth now, is because they want to be aerodynamic. Fuel efficiency doubled between the mid-70s and 80s, but then the problem is SUVs got super popular. So it declined after that as larger vehicles became more popular. Like a small car is going to be more efficient than a large SUV. So changes in regulations allow utilities to make more money by generating less electricity. So these programs provide incentives for conservation, which ultimately results in reduced emissions. So power companies are trying to give consumers incentives to not use as much energy. Utilities make money if they can help consumers save energy because they don't have to build new power plants because they can keep using the same ones they have. So consumer incentives can include things like cash rewards. None of my utility companies do that. Free energy efficient light bulbs, energy efficient air conditioners, and other appliances. Utilities themselves need to be more energy efficient and use things like cogeneration and improve power grids and reduce transmission loss. So the utility companies themselves, they need to be efficient, and we as consumers need to be efficient with how we use our energy. So the average household spends several thousands of dollars per year on utility bills. I can attest to that. I pay my bills every month. So costs could be reduced by having an energy efficient home. It might cost more up front, but the improvements usually pay for themselves in 2 to 3 years. So like it might cost me a lot of money to put photovoltaic cells on my roof, but every single month when I'm not having to pay an electricity bill, it will repay for itself in a few years. So, is there really super efficient places that you can live? Well, yes, there is. Hearst Tower in Manhattan, New York. It has 26% higher efficiency than standard office buildings. This is what it looks like. It looks super awesome. So it has a diagrid design. You'll notice like all the triangles that come together. And uses 2,000 tons less steel. 90% of the steel they did use was recycled. It has efficient cooling and heating systems. This part's really cool. So it actually has a 10-story, it's called an Icefall, that cools the atrium and irrigates plants. So in other words, it's like a waterfall, and as it's falling through the air, it cools the air, and then as it gets on the bottom, it waters plants that are inside the building. I thought that was kind of cool. And then the water comes from collected rainwater, so they're trying to be, more environmentally friendly there. Because it's all glass on the outside, natural light is enhanced by careful wall and partition use, so they don't have a lot of interior walls blocking that sunlight. And then they use low vapor paints, low toxicity sealants, and low toxicity carpets and sustainable materials. So see, it is possible. Now, of course, was this building super expensive to build? Most likely. But after a few years of not having to pay as many bills for all of this stuff, then it should pay for itself. But see, that's the problem, is a lot of people don't have extra money up front. So again, as I keep talking about, pros and cons to everything. All right, so that is chapter 18 on renewable energy resources.